Have you ever looked up at the night sky and felt a sense of wonder? A feeling that there's so much more out there than we can see? Or have you ever considered the strange, almost magical rules that govern our own reality? Science has given us incredible answers, from the smallest particles to the vastness of space. But for every question answered, new, even more profound mysteries emerge. Today, we're diving headfirst into some of the biggest unsolved mysteries that still have scientists scratching their heads. These are the puzzles on the very edge of human knowledge. The questions that could one day rewrite everything we think we know. Let's start with a big one. The universe itself. We know the universe is expanding, and not just expanding, but accelerating. Something is pushing everything apart, defying gravity on a cosmic scale. Scientists call this mysterious force dark energy. Here's the crazy part. Based on our best calculations, dark energy makes up about 68% of the entire universe. Think about that! More than 2/3 of everything that exists is a complete mystery. We can't see it. We can't touch it. We can't detect it directly. We only know it's there because we see its effect on galaxies flying away from each other. What is it? Is it a property of space-time itself? A new kind of energy field. We simply don't know. And figuring it out is one of the ultimate goals of modern cosmology. But dark energy isn't the only dark mystery out there. Let's talk about its partner in crime, dark matter. When astronomers look at galaxies, they see them spinning. But they're spinning so fast that, based on the visible matter, the stars, gas and dust should be flying apart. The gravity from what we can see isn't strong enough to hold them together. So, there must be extra mass, extra gravity, coming from something we can't see. This invisible stuff is what we call dark matter. It makes up about 27% of the universe. So, if you add that to dark energy, it means that a staggering 95% of the cosmos is made of things we do understand at all. All the stars, planets, galaxies, all the things we've ever observed make up just 5% of reality. We've searched for dark matter particles in deep underground labs, trying to shield our detectors from other cosmic rays. But so far, nothing has definitively shown up. Is it a new type of particle? Something completely outside our standard model of physics? Or is our understanding of gravity itself flawed on large scales? The hunt for dark matter is a race to understand the very structure of our universe. Now, let's bring it from the cosmic scale down to the realm of life itself. Where did life come from? This is the question of abiogenesis, the process by which life arises from non-living matter. We know the basic ingredients were present on early Earth. Water, carbon, amino acids, and energy from lightning or volcanoes. Scientists have even shown in labs that under the right conditions, these simple building blocks can spontaneously form more complex molecules, like proteins and RNA, which are essential for life. But there's a huge gap between a soup of complex molecules and the first self-replicating living cell. How did these molecules organize themselves? How did the first cell membrane form to protect the delicate machinery inside? How did the incredibly complex genetic code the software of life come to be? It's like finding a fully functional computer on a deserted island. You might see the sand, metal, and silicon it's made from, but you'd have no idea how those raw materials assembled themselves into something so complex and functional. Was it a lucky chemical fluke in a warm little pond, or did it happen in the scorching heat of deep-sea hydrothermal vents? Or, as some theories suggest, did the building blocks of life arrive on Earth from space, hitching a ride on asteroids or We are still searching for that definitive spark that ignited life on our planet. And that leads us to another profound question. Are we alone in the universe? With billions of galaxies, each containing billions of stars, many with their own planets. It seems statistically unlikely that Earth is the only place where life has taken hold. This is the heart of the Fermi paradox, which asks, if the universe is teeming with life, where is everybody? Why haven't we seen any signs of intelligent alien civilizations? No radio signals, no giant alien megastructures, no starships zipping through our solar system. There are many potential answers, or filters, as they're called. Maybe life itself is incredibly rare. Maybe intelligent life is rare. Or maybe intelligent life inevitably leads to self-destruction before it can master interstellar travel. Perhaps they're out there, but they're deliberately hiding from us, observing us like a cosmic nature preserve. Or maybe the distances are just too vast, and we are, for all practical purposes, alone in our cosmic neighborhood. The search for extraterrestrial intelligence, or SETI, continues to scan the skies, listening for a single, faint signal that would change humanity's place in the cosmos forever. Finally, let's turn inward to the most complex and mysterious object we know of in the entire universe. The human brain. Right now, inside your head, about 86 billion neurons are firing, creating your thoughts, your memories, your emotions, and your sense of self. This intricate network of connections somehow gives rise to consciousness. But how? How does the physical firing of neurons create the subjective, private experience of seeing the color red, or feeling happy, or wondering about the universe? This is known as the hard problem of consciousness. We can map the brain. We can see which areas light up when you feel a certain emotion or perform a certain task. But that doesn't explain the why. It doesn't explain the feeling itself. Is consciousness an emergent property of complex systems, something that just happens when you have enough interconnected parts? Is it something more fundamental to the universe, like mass or spin? Philosophers and neuroscientists have been debating this for centuries, and despite our incredible advances in brain imaging, we seem no closer to a definitive answer. Understanding consciousness isn't just about understanding the brain. It's about understanding the nature of our own existence. From the nature of reality to the origin of life and the seat of our own thoughts, we are surrounded by profound mysteries, and that, in itself, is beautiful. It's the not knowing that drives us forward. It's the curiosity that fuels science and pushes us to build bigger telescopes, deeper particle accelerators, and more powerful computers. These unanswered questions are not a sign of science's failure, but a testament to its endless frontier. Every generation of scientists solves old puzzles and uncovers new, even deeper ones. What mysteries will we solve in our lifetime? And what new questions will we leave for the generations that follow? The journey of discovery is far from over. Thank you so much for joining me on this journey through the unknown. If you enjoyed this exploration of science's biggest puzzles, please hit that like button and subscribe to the channel for more deep dives into the wonders of our universe. Let me know in the comments which mystery fascinates you the most. Until next time, stay curious.